Hello students, welcome to Screencast number 6. This one's all about domain and range. What you're looking at right here in this crazy looking photograph is an actual home in Minnesota. That's right, this is an actual home that is called the foam home. Yes, as you can see from the picture, it is appropriately named. It is $194,000. It is 4,080 square feet. It has 2 bedrooms and 3 bathrooms. Now, why am I telling you this? No, I'm not trying to sell you this home, although if you want to buy it, I can give you the information of the realtor. No. Today's question is all about driving home, or at least traveling home, which is someplace I know we all like to be. Here's the question. You are 420 miles from home, and you are driving toward home at an average rate of 60 miles per hour. Not bad. The distance d in miles away from home after t hours is given by the function d is equal to 420 minus 60t. In other words, d represents the distance you are from your home, and t represents how many hours you have been traveling to get to your home. What we have to do is the following. Graph the function and identify the domain and the range. And then we'll explain how we determine the domain and the range. All right, I'm going to do all that for you, of course. And then, after that, present to you your own similar real-world problem. Now, nicely enough, the graph that we need to use is right here to the right, okay? So, no need for you to recreate your own, especially on the one that you're going to do. I have provided the graph for you, and I'll show you how. I'll explain to you how you can just use that as a screenshot in order for you to complete your work. Anyways, let's get started. So here we have the problem again, and I've set up some very valuable information for us. Let's see what this means here. The equation itself, d is equal to 420 minus 60t. Again, that represents you start 420 miles from home, and you're driving at a rate of 60 miles per hour, which means we are subtracting 60t, because for every mile that we drive, for every hour that we drive, another 60 miles comes off, is removed from, or is subtracted from the 420 miles we are from home, which is why the equation is 420 minus 60t. 60t, remember, 60 miles per hour. All right, so that makes sense. Now, let's look at over here. Here we've created our input-output table. But, in class we did x and y. Well, keep in mind, those variables, x and y, can literally be anything. So we're using t and d here because that's what it's used in the equation. But let's look at the graph over here. Notice that t, over here on the right, all the way far here, is along the horizontal axis, which we know as the x-axis. Well, anything that's along the horizontal axis, the x-axis, that is always going to be our input. Yeah, that's going to be our input. And anything along the y-axis, like here, the distance, which of course is called d according to this problem, well, that's going to be our output. Knowing this, we're able to set up our table thusly. T and d. So our input values, t, we're going to input time on the left, and our distance, how much distance we have left, will be on the right. All right, so let's begin doing this. What we're going to do first is we're going to calculate all that we need to, and then we'll graph all of our points. So we'll do the graphing at the end. Let's just do the actual mathematics right now. Now, where should we start? Well, keep in mind we're dealing with time in hours. And you know for certain that you can't have -1, -2, -3, -4, -5 hours. Negative hours, negative time, does not exist in the real world. So let's start with the first hour that we can safely calculate with. And technically, it doesn't have to be 1. What we can use, of course, is 0. So after traveling for 0 hours, how far are we from our home? Now, of course, the answer is obvious. We're still 420 miles from our home. Well, let's confirm that. What we're going to do is replace the variable t with what we believe to be our first time. In other words, our first input, which is 0. So t is 0. All right, so now everything we didn't touch simply comes down around it. 420 minus 60 times 0. All right, well, we know 420 minus, well, 60 times 0 is 0. So we're left with 420, which confirms what we just said. All right, good to know. So when t is 0, in other words, we haven't traveled any number of miles, the distance is still 420. All right, well, let's move on to the next hour. So now that we know that when time is 0, the distance is still 420, let's go to the next hour. Now keep in mind, it's domain. We can choose anything that we want. All right, so I'm going to keep it simple still. Let's say our next time that we want to calculate is 1. So t is now 1. So get rid of t. Bam, there it goes. And replace it with the number 1. So in other words, we've driven for 1 hour, which means 60 miles per hour is what we're driving, so 60 miles are done. All right, so let's see here. We got 420 minus, of course, 60 times 1 is 60, and 420 minus 60, 360 miles now. So after 1 hour, we still have 360 miles to go. All right, so we're doing well. Now again, nice thing about domain is that we can literally choose anything we want. And we could, if we wanted to, waste a lot of time saying, okay, after 2 hours, after 3 hours, blah, blah, blah. I think we are smart enough to kind of skip ahead. Yeah. Let's jump from 1 hour directly to 4 hours. So let's say the next time that we want to calculate is not 2 hours or 3 hours. Let's say it's 4 hours. All right, so we replace the t with 4. And I'll explain why we can do that in just a moment, all the way at the end when we're talking about the actual domain and range. So let's see here. 420 minus 60 times 4, 240. So after 4 hours of driving, 180 miles are left. That's really nice. So we kind of get to jump ahead. Still within that vein of jumping ahead, I think it would be nice if we skip to maybe 6 hours next. Yeah, we could do 5 hours, but why? We don't really need to, and we'll talk about that in a moment. All right, so get rid of t, and now let's replace it with 6 hours. So our mathematics is still 420 minus 60 times 6. Oh, okay, well 60 times 6 is 360. And look at that, we are getting very close to home because 420 minus 360 is 60, so we only have 60 miles to go. So we're getting close. All right, so let's do the next one. Now again, we can choose any next logical time that we want. We could even do 6.5, we can do 6.25, we can do 6.75, we can do 6.3892. You get the idea. But it does help us to keep this in terms of whole numbers. So what if the next time that we wanted to figure out was 7? Okay, so let's get rid of that t and let's replace this with 7. So now the math that we do is very similar to what we've been seeing. 420 minus 60 times 7, hey, that's also 420, which means the distance that we have remaining from home is 0, which means we have reached home, which means we don't have to calculate anything anymore. Nay, we shouldn't calculate anything anymore. We are, in fact, done with the mathematics because the distance from home is now 0 miles, which means you have arrived at home. Now, just for fun, what if we actually did keep going? In other words, let's say we said, oh, what happens if I travel for 8 hours? All right, so let's do the math here, and let's see what our number is, and if it does make sense. All right, so 60 times 8, of course, is 480, and 420 minus 480 is negative 60. In other words, we're dealing with a distance of negative 60 miles. We are negative 60 miles from our home? We've talked about this in class. You can't have negative distances in the real world. That is impossible. So, doing anything higher than 7 for your time is not only unnecessary, it gives us a ridiculous answer. We don't need any of this. No, we don't. We just need to stop when 7 is t, because d was 0, and thus we've reached home. So now that we have all this wonderful information here, time is 0, 1, 4, 6, 7, which means d is 420, 360, 180, 60, and finally 0, we are able to now officially plot our points. All right, so here we go. Please notice on the right I have moved all of our good information over, and I have enlarged our graph so we can now use this. All right, so let's do this. You know what? Let's start with 0, 420. Okay, well, 0, 420. 0, 420. That's going to be a little bit above 400, but not quite above the halfway point between 400 and 500. About right there. Our next point, 1, 360. Now remember, T is our input value. D is our output value. So along the x-axis, we need to go to 1 and then go up to 360, just like we did for the first point. We went from 0 up to 420. So now we go to the right one and up 360, which is going to be a little bit above the halfway point between 300 and 400, about right there. Good. Our next point, 4, 180. So we go to the right 4, because 4 is the number of hours, and we go up to 180, which is going to be closer to 200 than it is 100, so let's put our point about right there. Not bad. Then our final point, our second to final point, 6, 660. So we go to the right 6, and then we have to go up to 60, which is going to be a little bit over the halfway point between 0 and 100, because you notice how this scale right here is 100, 200, 300, 400, 500. In other words, it's going up by 100. So let's see here. 660 is going to be about right there. And then the easiest one, 7, 0. So we go to the right 7, and then do we go up any? No, because our distance is officially 0. So right there. Nice. Now look at those points. They do form a straight line. Beautifully, in fact. And one thing we always want to do when we're dealing with a linear equation such as this is connect them with a straight line. So in order to do that, I want to do this as accurately as possible. So let's get a line going. There we go. And it's connected with a perfectly straight line. Here, let's see this again a little bit larger. There it is, folks. Very beautiful. As you can see, it does form a perfectly straight line. Now, one thing I want us to talk about now was, you notice how we went from 1 hour, and then we went to 4, and then we went to 6? What about 2 and 3 and 5? Heck, what about 1.5, 2.5, 3.5, 4.5? Notice that we did skip those in the interest of time, because if we considered all decimals in between 0, 1, 2, 3, 4, 5, 6, and 7, we would literally be spending the rest of our life doing this, because there's an infinite number of decimal numbers in between any two consecutive whole numbers. I mean, think about it. In between 4 and 5, there's literally an infinite number of decimal numbers that you can use. We don't have time for that. This line took care of that. It's as if we did a dot, 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 at every single number. And if you can imagine every single number being dotted, 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 then if you look at it from afar, it would just be a straight line. So to save us some time, we simply create the straight line to sort of trick everyone into thinking that we did do dot, 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 and then again dot, 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 dot. We don't have to do that now because it saves us some time. Which means, based on this graph, we could see that if we did, say, drive for maybe 2.5 hours, which is right here between 2 and 3, we would be approximately, well, we'd stop right there on the line, we'd be a little bit less than 300 miles away. And if we did drive for 5 hours, which we didn't calculate, based on this line, we could see that, oh, we'd probably be a little bit over 100 miles away. You know, right there. So we did take care of the ones that we had to skip, the ones that we chose to skip, because this line took care of that. This line takes care of all the ones in between the numbers that we didn't have to calculate. And we also have to indicate that in our domain and our range, because keep in mind, yes, it is possible to drive for 1.5 hours or 2.5 hours, 3.5, 4.5. Heck, it's possible to drive for 5.75 hours, all right? So we indicate that this way with this line, which indicates all the numbers in between 1, 2, 3, 4, 5, 6, 7, but also with our domain. Let me show you how that works now. Remember something, and you can see our graph is right here in the corner again. Our input values were time, 0, 1, 4, 6, and 7. That's what we chose to do. And remember, the input is always along the horizontal axis, and the output is always along the vertical axis, the y-axis. So the d values, 420, 360, 180, 60, and 0, those would be our output and our input. So the input is on the left, and the output is on the right. Now, we got to give these their proper names. Keep something in mind. The input values, the set of all of them, is called the domain. So we are almost done. We have graphed it, and now we have to state the domain and, of course, the range. Yeah, the output values. Those are known as the range. All the sets of output values. Keep in mind what I just said here. All the values of the output is called the range. And all the input values are called the domain. Did we list every single value here? No, we did not. Notice that we left out 2 and 3. Notice that we left out 1.5. Notice that we left out 4.689. Notice that we left out 6. You see where this is going. So how do we indicate to someone every single number that exists, that possibly exists, including all decimals and all fractions, in between the numbers 0 and 7? Because remember, we said you can't do a -1, because that doesn't make sense, -1 hours. And we're not going to go beyond 7 because we saw that if we did, we'd have a negative distance of -60. And of course, if we went beyond 7, we do 8, 9, 10, 11, all of those would still give us a negative distance, which is ridiculous. Why would you keep traveling if you've reached home at 0 miles from home? So how do we indicate every single number, including all decimals and all fractions, in between 0 and 7? We use an inequality. More specifically, we use a compound inequality. Compound means more than one. We're going to be seeing compound inequalities a lot this year, so let's get used to seeing them right now. We're not just going to say the domain is 0, 1, 4, 6, and 7. No, because remember, we left out all the numbers in between them. So we have to indicate that. Now remember, t is our input variable. So the way you make a compound inequality, it's not that bad. First, put your variable in the center of it all. So, t. Now, what is the minimum, the very least, the very smallest number that you can have in your domain? We saw that it's 0. So we're going to put that 0 on the left of the variable. Now, what's the maximum number, the highest number, the greatest number that we could input? Well, we saw that it was 7. So therefore, 7 goes on the right. Now, what did I say we're going to create? A compound inequality. That's right. So you're going to use the two less than or equal to symbols between the 0 and the t and the t and the 7. Because what you're saying here by creating this is that your time t is between 0 and 7. More specifically, if we looked at it piece by piece, time has to be less than or equal to 7, or time is greater than or equal to 0. And if you read this from left to right, here's what you're saying. 0 is less than or equal to the time, which is also less than or equal to 7. That makes sense. 0 must be less than or equal to the time, which is also less than or equal to 7. In other words, any time that you have must be between 0 and 7. By stating it like this, you are including all the numbers in between 0 and 7, which include all the decimals and all the whole numbers in between as well. That's your compound inequality, which means we have to do something similar to the range. Now notice that with our range values, we had 420, 360, 180, 60, and 0. Well, are there numbers that exist between 420, 360, 180, 60? In other words, if we did, in fact, calculate for, say, 1.5 hours, wouldn't that number be greater than 360 and less than 180? Or what if we calculated for 5 hours exactly? Wouldn't that number be between 180 and 60? But again, to save us some time, we don't have to calculate everything. We just have to indicate to someone every single number that is between 420 and 0. So we also create a compound inequality. Both your domain and range are going to be compound inequalities. Now the variable for this was distance. So let's use that variable once again, d. Now here's how you create your compound inequality. What was the least number, the smallest number, the very last number? Well, it's not 420 this time, of course, it's 0. So, smallest number on the left. Biggest number, which as we can see here is 420, on the right. And in between them, once again, we need our inequality symbols. Less than or equal to, less than or equal to. Both pointing to the left. We need the less than or equal to symbols. Now, why or equal to? Well, keep in mind that is including 0 and 420. I mean, can the distance be 0 miles from home? Yes. Can the distance be 420 miles from home? Absolutely. Again, with our domain here, can our time be 0 hours? Yes, so we use the or equal to part. Can the time be 7 hours? Yes, of course, so we use the or equal to part. Now our range is between 0 and 420. In other words, our distance is any number that is between 0 and 420. Reading this left to right, we're saying 0 is less than or equal to the distance, which is also less than or equal to 420. And if you think about that sentence, what you're saying is any number that is between 0 and 420. Thus, we have the domain stated correctly. Thus, we have the range stated correctly. And this is how we're going to start to state our domain and range from now on, more accurately than what we saw in class today. So, in summary, and I know what you're thinking right now, oh, thank God, conclusion, we're getting there. I understand. In conclusion, our domain is 0 is less than or equal to t, which is less than or equal to 7, which indicates all numbers between 0 and 7. So the number of hours must be between 0 and 7 hours. And our range is 0 is less than or equal to d, which is less than or equal to 420, which indicates the distance must only be between 0 and 420 miles per hour. And here's our graph, once again. So we have followed the instructions beautifully. We have graphed the function, and we have stated the domain and the range, and I have explained how we got the domain and range at great lengths. I'm sure you're very done with this. But wait. It's time for your problem. Here is your problem, ladies and gentlemen, and as you can see, I've sort of set up some good information for you. A rental shop at a lake rents paddle boats. Those are awesome. If you ever had a chance to get a paddle boat, trust me, you won't be sorry. A rental shop at a lake rents paddle boats for $3 for each half hour. The total cost, C in dollars, okay, there's C, for renting a paddle boat H, there's H, half hours is given by the function C is equal to 3H. Here it is again. Once you get to the rental shop, you figure you can rent the paddle boat for at most 4 hours. That is important information. If you can only rent it for at most 4 hours, either H or C, I will let you decide, must be at the most the number 4. Well, would that be H or would that be C? Graph the function right here and identify its domain and range. Very similar to what you have seen here. I sort of gave you a template for the domain and the range because this is kind of new for us. Remember, the domain are the input values H, so H is in the center, and the range are the output values C. It's your duty to find what the lowest number and the highest number in the domain are, and what the lowest number in the range and the highest number in the range are, and of course, indicate that on the graph here as well. And then, one more question. What is the most that you will pay for renting a paddle boat? Now, how can we figure that out based on this information here? Remember, you can rent a paddle boat for at most 4 hours. That's all the time you have. So what is the most that you will pay for renting a paddle boat, knowing full and well that you can only have it for 4 hours? That's up to you. That's up to you to calculate. Now, to help you out in the graphing part, so you don't have to recreate this, feel free to simply take a screenshot of what you're looking at right now, and then just copy and paste it into whatever medium you need. I hope that helps you. So there we are, folks. That's your problem, and we're done. If you have any questions, feel free to contact me. Oh, and also, feel free to click the Batman logo written as a linear equation on the left of your screen to subscribe to this channel so you can see this screencast and, if you want, screencasts from all classes. And feel free to give them a try as you want. And also be sure to follow me on Twitter at Mr. Ripes. That's R S on Twitter. All right. Good luck, folks.